Okay, this is it. This is the second lecture in linear algebra, and I've put below my main topics for today. I put right there a system of equations that's going to be our example to work with. But what are we going to do with it? We're going to solve it. And the method of solution will not be determinants. Determinants are something that will come later. The method we'll use is called elimination, and it's the way every software package solves equations. And so, elimination, well, if it succeeds, it gets the answer. And normally it does succeed. If the matrix A that's coming into that system is a good matrix, and I think this one is, then elimination will work. We'll get the answer in an efficient way. But why don't we, as long as we're sort of seeing how elimination works, it's always good to ask, how could it fail? So at the same time, we'll see how elimination decides whether the matrix is a good one or has problems. Then to complete the answer, there's a obvious step of back substitution. In fact, the idea of elimination is, you would have thought of it, right? I mean, Gauss thought of it before we did, but only because he was born earlier. It's a natural idea, and died earlier too. Okay, so, but then, and you've seen the idea. But now, the part that I want to show you is elimination expressed in matrix language, because the whole course, all the key ideas get expressed as matrix operations, not as words. And one of the operations, of course, that we'll meet is how do we multiply matrices and why. Okay, so there's a system of equations. 3 equations and 3 unknowns. And there's the matrix, the 3 by 3 matrix. So this is the system, AX equal B, you could say. This is our system to solve, AX equal, and the right-hand side is that vector 2, 12, 2. Okay. Now, when I describe elimination, it gets to be a pain to keep writing the equal signs and the pluses and so on. It's that matrix that totally matters. Everything is in that matrix, but behind it is those equations. So what does elimination do? What's the first step of elimination? We accept the first equation, it's okay. I'm going to multiply that equation by the right number, the right multiplier, and I'm going to subtract it from the second equation. With what purpose? So that will decide what the multiplier should be. Our purpose is to knock out the x part of equation 2. So our purpose is to eliminate x. So what do I multiply? And again, I'll do it with this matrix because I can do it short. What's the multiplier here? What do I multiply? Equation 1 and subtract. Notice I'm saying that word subtract. I'd like to stick to that convention. I'll do a subtraction. So first of all, this is the key number, right, that I'm starting with. And that's called the pivot. I'll put a box around it and write its name down. That's the first pivot. The first pivot. Okay, so I'm going to use, that's sort of like the key number in that equation. And now what's the multiplier? So I'm going to my first row won't change, but that's the pivot row. But I'm going to use it, and now finally let me ask you what the multiplier is. Yes? 3. 3 times that first equation will knock out that 3. Okay, so what will it leave? So the multiplier is 3. 3 times that will